A computer is an electronic device that can take inputs, process them, output the results, and store those results for later use. This is a neat definition because it allows for a computer to be more than just the thing that sits on top of your desk. A computer can be a tablet, a smartphone, or even a programmable thermostat. The information processing cycle is a model we use to show how different hardware components work together. Everything starts with input devices. An input device is anything you use to put data into a computer. Things like cameras, scanners, mice, keyboards, or microphones. All this data is converted into a digital format and sent to memory. Digital data is represented by bits. A bit is a 1 or a 0. Computers are machines that only understand two states. There's either a charge or there's no charge. There's either a positive magnetic polarity or a negative one. Light is either reflected or it's not. When you group 8 bits together, you have a byte. A byte is roughly equivalent to a character. The word byte would be 4 bytes since it has 4 letters in it. Once you have 1,000 bytes, you have a kilobyte. A megabyte has 1 million bytes, a gigabyte has 1 billion bytes, and a terabyte has 1 trillion bytes. If you want to get technical about these prefixes, a kilobyte is actually 1,024 bytes, and a megabyte is actually 1,048,576 bytes. These numbers come from the binary system. Since there are only 2 states, on or off, prefixes are based on a base 2 system. So a kilobyte is 2 to the 10th, or 1,024 bytes, if you multiply that out. A megabyte is 2 to the 20th, or 1,048,576 bytes. A gigabyte is 2 to the 30th, and a terabyte is 2 to the 40th. There are other units past a terabyte, but at a consumer level, we won't ever deal with petabytes or exabytes. Those are usually terms used on servers or when dealing with lots of data. When a computer works with data, that data has to be represented by ones and zeros. Random access memory, or RAM, or just memory, holds all these ones and zeros until they're ready to be processed, and memory holds the result of that processing. Memory is measured by how much data it can hold. Typically, you'll hear computers with 4 gigabytes or 8 gigabytes of memory, while some higher-end ones may have 16 gigabytes. This capacity is important in the grand scheme of things because it relates to how much you can do with your computer at once. Think of memory as the space on your office desk. You're limited by the surface area on your desk in laying out different reports or having post-it notes everywhere, along with your pens, calculators, and coffee mugs. If you run out of space on your desk, your productivity slows down, and you'll have to move stuff off your desk to make space for more stuff. But if you have a larger desk, you have more space for more stuff. The same goes with memory. If you have 4 gigabytes of memory, that limits how much data you can input through your cameras or keyboards. When you have different programs running, that uses memory as well. So if you find your computer is running slowly when you have 6 browser tabs open while streaming Pandora and working on a PowerPoint presentation, you may have to close some of the things down. Your computer can't handle all of that because its desktop space, or memory, is limited. The alternative would be to get a bigger desk, or to increase your memory, which actually isn't a hard upgrade to perform if you want to try that yourself. You may hear a lot of terms when talking about memory, such as SODIMM, which is Small Outline Dual Inline Memory Module, or DDR, which is Dual Data Rate. A lot of these will be specific to the computer you're using. For example, laptops use SODIMM memory because of their size, and some computers can only use DDR3 memory and not DDR4. If you want to upgrade your memory, visit a site like Crucial.com, put in information about the computer you're using, and the site will tell you exactly what you need to buy if you want to upgrade your memory. Your central processing unit, or CPU, or just processor, is responsible for making sense of all the bytes of information that's sitting in memory. Computer processors are generally made by either Intel or AMD. The i3, i5, and i7 processors are made by Intel, as are Pentiums and Celerons. AMD makes Ryzen and Athlon processors. These have slight differences in the way they do things, and in a business sense, for the most part, it doesn't really matter which brand you use. At their core, processors do the same thing. They grab some data from memory, process it, and put it back into memory. But there are a few specifications worth noting. The amount of data a processor grabs from memory is the word size. A 64-bit processor grabs 64 bits of data from memory every cycle. This is different from 64-bit programs. A 64-bit processor can run 64-bit or 32-bit programs, but a 32-bit processor can only run 32-bit programs. CPUs are sometimes noted for how fast they can process things. Hertz is a unit of measure that represents a cycle per second. When a processor gets data, processes it, and puts it back into memory, that's one cycle. CPUs can go through this cycle many times per second. If you ever see a processor described in hertz, such as a 3.6 gigahertz processor, That means the processor is capable of the get, process, put back cycle 3.6 billion times per second. The prefixes for processor speeds are the same as with memory capacities. Kilo is 1,000, mega is 1,000,000, and giga is 1,000,000,000. A CPU is made up of a control unit and arithmetic logic unit, which, when taken together, are the core of a CPU. Modern processors usually have multiple cores. If you see a processor advertised as a quad-core CPU, that means it has 4 separate control and ALU pairs working in tandem with each other. Once a CPU has processed the raw bytes that came from your input devices, your computer is ready to output that for you to use. Output devices include monitors, printers, speakers, or even vibrating motors like the Taptic engine in iPhones. If you need to keep data for use later, use a storage device. Storage devices consist of optical drives, floppy drives, hard drives, and solid-state drives. Capacity for storage devices uses the same terminology as memory, so you'll hear drives as having 256 gigabytes or 2 terabytes worth of storage. Floppy and hard drives work on magnetic principles. The disks themselves have magnetic particles that are oriented a certain way so that when a read-write head passes over them, they represent ones and zeros based on the polarity that the read-write head senses. Optical drives work by reflecting light back to a source. Data on optical disks are arranged in a spiral like vinyl records. A laser shines on the surface of an optical disc, and if it's reflected, that particular spot represents a 1, and if it isn't reflected, then that spot represents a 0. Solid-state drives work by using flash memory chips, the same kind of chips in your USB drives. SSDs are becoming more popular nowadays because they are faster than traditional hard drives, and because they don't have any moving parts like a hard drive does, they're more reliable. However, they're still more expensive than hard drives on a per byte basis. A 1 terabyte hard drive may be selling for $45, but a comparable 1 terabyte solid-state drive may be selling for $115. Sometimes people refer to memory as primary storage and hard drives as secondary storage. This makes sense somewhat since both store data. The only difference is that memory stores data that the CPU directly accesses, and hard drives store data that is passed along to the CPU through memory. You might also hear RAM being referred to as volatile and storage devices as non-volatile. RAM needs a constant source of power to maintain the data stored on it. Without power, the data on RAM is lost. Storage devices don't require power to store data. Yes, they require power to write the data, but once the data is written on the drive or stored on the flash chips, they don't require power to maintain that data. Software is a list of instructions that hardware follows. Software consists of programs written in a language like C++ or Java. The purpose of software is to use hardware to do things, from crunching numbers to watching videos to controlling the temperature in a household. Hardware is as good as a bag of rocks without software telling it what to do. There are many ways to categorize software. One way is by function. Software can be either in control of the system, or it can provide functionality for the user. Software that controls hardware is an operating system. An OS interfaces directly with hardware to perform mathematical and logical functions. Functional software is an application. End users will use a program like Excel to calculate different sales and profit figures for a company, or Outlook to get in touch with clients to set up appointments. Applications interface with the OS to use the hardware to make this happen. If Excel needs the processor to perform some mathematical calculations and show the results on the screen, the OS works with the CPU and monitor. Software can be categorized by where it is installed. Local installations, also referred to as on-premises installations, are applications that are installed on a local computer or server. These kinds of installations fall under the responsibility of the individual user or IT staff to maintain, upgrade, or uninstall. Sometimes local installations are synonymous with the term thick client application. Cloud installations are applications that are installed on someone else's server and accessed through the internet. Microsoft Office 365 is a perfect example of this. You can create documents or spreadsheets online through a web browser without installing the actual programs on your computer. Maintenance of cloud installations falls under the responsibility of the host. As a user of a cloud-based program, your only concern would be your internet connection. You never have to worry about any software patches or updates. Sometimes these are also referred to as thin client applications. Sometimes software is classified by its target audience. Horizontal market applications, sometimes just called horizontal applications, can work for many different types of companies and industries. These are some of the more popular names you might hear, like Microsoft Office or Adobe Photoshop. Vertical market applications work for a specific industry. Patterson makes software for dental offices. You'll never see Patterson software used by your average everyday consumer. Licensing is another way to categorize software. Software generally comes with a licensing agreement that lets you know what you're allowed to do with the software before you install it. Commercial software generally lets you use the software as is, and sometimes lets you install it on multiple computers. Some consumer-level antivirus programs allow for installation on 3 to 5 personal devices. In some cases, companies buy a site license so they can install a program on all the computers at their location. The site license may allow for installation on up to 500 computers, for example. Open source software, on the other hand, not only allows you to use the software as it was intended, but it also lets you modify the underlying programming code to add, change, or delete features to it. Commercial software is controlled by the company that created it, and because it's their intellectual property, they don't want people seeing how it works by analyzing the underlying code. In their end-user license agreements, you'll usually see something about not being allowed to decompile or reverse engineer the program. Open source software, on the other hand, isn't controlled by anyone. The open source community contributes to software development, and the software itself is free for anyone to use. From both a business and a consumer standpoint, both commercial and open source software has its appeal. Commercial software is supported by a company, so if anything ever goes wrong, that company will work hard to fix things. It's their reputation and financial well-being on the line, after all. Open source software, on the other hand, isn't supported by any one company, so if there's a problem with a program or if there's a feature request, there's no one to be held accountable for fixing the problem or adding a new feature. Cost is also a big difference between the two. Commercial software, with the support that comes with it, usually comes at a price, while open source software, as we mentioned earlier, is free for anyone to download and use. There's also the issue of version control. Windows 10, for example, is pretty much the same across the board, but Linux, because of the nature of open source software, has hundreds of versions or distributions available for use. Let's look at some different applications. Microsoft Windows would be a locally installed commercial operating system that everyone can use, thus making it a horizontal application. Other popular operating systems include Mac OS, used on Apple desktops and laptops, iOS, used in Apple iPhones, and Unix, which is generally used by engineers and other technical disciplines. We mentioned Linux. That's an example of a locally installed open source operating system. There are many different distributions of Linux, including Red Hat, Puppy, Mint, Debian, and Ubuntu. We mentioned Microsoft Office. Office 2019, or generally any version of Office with a year after it, is an example of a locally installed commercial application. Office 365 is an example of a cloud-based commercial application. OpenOffice is like Microsoft Office, but it is open source. Files aren't fully compatible between the two because of the way the two applications handle formatting and other details. We mentioned Patterson. That's an example of a locally installed commercial vertical market application. BD also makes software that works with the medical field and is pretty useless for non-medical professionals. It's important for us to understand what our options are in the vast world of software. Remember that as IT professionals, we don't just buy things just because. There always has to be a reason behind that purchase, and that reason is usually tied to improving business processes to increase the company's margin so they can stay competitive within their industry.